Let's try it again. Okay, so I set the things up the way I wanted to. So this is what you should see. Once you have access to MyLu Online, when you go to your assignment, you're going to start by finding what's known as the invitation link again. So this is assuming that you've got your Docker set up and running in order to follow exactly what I'm going to show here. So Docker VS Code is up and running, and you've got your secure shell key created with your GitHub account, and you've got Git all set up. Okay? So when you click on the invitation link, it's going to create a repository for you. The very first time you do this, make certain you select your name, the correct name in the gradebook, and accept the assignment. So once I've accepted the assignment, it actually creates a repository for me that I should have read-write access to. Okay? So you can always get back to this repository by re-clicking on that invitation link, or I usually just go to my GitHub account. And so, you don't actually own that repository. My organization owns it. So if you go to GitHub, pull down and look at your organizations, I'm going to be a member of a bunch of organizations, but unless you've been doing a lot of stuff, you'll probably only be a member of like my CSci 574 organization. So for the spring 2026, here's what I'm doing. So you should find yourself as a member of something like the 574 spring 2026 organization. So if you go and look in there, you'll be able to see your repository. So again, I'll be able to see everybody, but you'll only be able to see the repositories that you're granted read-write access to, including this assignment one repository that I just accepted and was created for me. So to get started, we want to start by cloning this repository. And again, I'm assuming that you've got your GitHub account set up and you've got your secure shell key working so that you can actually create commits and push them. So we're going to clone using the SSH key of the repository that we have access to. So I'll just copy that key. So, you can use any kind of Git tool to do a clone and the other Git commands I'm going to show here, but you can do this from VS Code, which is the way I recommend doing it for this class here. So I go to the source control and do a clone repository and just paste that URL on there. Okay? And don't clone from GitHub, just clone directly from the URL. Okay? You have to select a location on your local system where you're going to put the repository into. So I've already got a repository of that name, but it will create the repository, and you should go ahead and open it up. So yeah, it depended on a one on there, but you should end up with a repository. Let me bring up my file browser here. So after I did the clone here, I selected my home repos directory on my local file system. And since I already had an existing one, this is the actual set of files from the assignment one for this assignment that was actually copied down when we did the clone here. Okay. You should, if you've got your Docker container up and running, you should be able to see a pop-up, and you always want to reopen it and run in the container. Okay. So the very first time you do this, when you create a container, it might take a little bit of time here. I've done these before, so it shouldn't take too long for me to create my container for the assignment one here. So the reason why I recommend using these Docker containers that we've set up is it actually installs the version of Python using the Anaconda installer, as well as the version of the libraries like scikit-learn and NumPy that we expect that you have for the assignment. And there's other advantages as well. So we set up some we set up some testing and some other things that you can do that we make it relatively easy to do when you're running the inside of the Docker container. Okay, so So it is going to take a little bit of time for me to create. It might even take longer for you. I probably already have a few things cached and downloaded. These components, what do they call them? The pieces of the Docker containers that are put together here based on our Docker setup here. Since I'm doing live streaming, I don't have the ability to pause here. So let's just go ahead and let this keep running here. So while that is running, so for the first assignment, it's mostly a warm-up assignment, just to make certain that you learn the basics of Python. So mostly there's 4 or 5 tasks that you have to complete for the first assignment, where each one you have to write a Python function or two. Okay? Probably the stuff, if you haven't done Python before, the newest stuff might be using what are known as NumPy NumPy arrays, and performing NumPy operations. Okay? So that's part of the assignment, is writing these functions in a particular way so that they're vectorized, so they have good performance for machine learning tasks. Okay, so we're still creating a container here. Let's see here. What can we talk about? So for this particular assignment, let me go back to look at the repository here. So there's not a lot of instructions here, just some basic instructions in the README. So for this particular first assignment, and for most assignments for this class in the machine learning, the instructions are actually in the notebook. Okay, so what you're mostly going to be doing is writing your code, writing your answers to the tasks that are set to you inside of the notebook. So you need to be able to run an IPython notebook. Also, though, you'll actually have to write your functions inside of the assignment task.py file in the source directory. So for this first assignment, you're going to be completing all these functions. So we actually gave you stub functions that aren't doing anything, right? So for the very first task, you have to write the implementation of this basic sigmoid function, right? So you're going to actually be putting your code here. So you don't, you're not supposed to return 0. You're supposed to return the sigmoid. So if you get x as input, you're supposed to return the sigmoid function x. And that's described a little bit in the notebook. But that'll be the basic workflow, is you'll usually put your functions in this assignment task source file, and you'll add additional code to use the functions and demonstrate the functions and do other things in the notebook. Let's see how we're doing on the container. We're still creating the container. So yeah, this is actually taking the full amount of time here. So I hadn't actually done this assignment before on this notebook, so I probably didn't have anything cached. So it will take a bit of time to download everything, to create the container from scratch, and then once it does that, it has to install the operating system and install the tools and things like that. So we're in the middle of those steps at this point. We're actually still creating the container right here when we're doing things. So since I can't pause here, let me move on to a slightly different topic while I'm waiting for that to finish off here. So the other repository that you will want to use and be aware of is the official course repository. So if you look at the additional resources, I already showed this link here, but the first one under the class materials is a link to another GitHub repository This one, so I already mentioned, this has the lecture notebooks and some other stuff in here that will be useful for the class. This one you won't have write access to, so but you can go and clone this repository. You can just clone it using the HTTP key. So that basically gives you a read-only version. So it basically just downloads the files if you clone it using this. So for the first 2 weeks, the lecture notebooks are for this first week. These first three, Unit 1-1, 2, and 3, are notebooks, and I've got lecture videos about the basics of Python programming. Right. So if you look on I'll bring up the video playlist again here. So if you look at the starting down here at 1-1, 1-2, 1-3, I do have some typical kind of lecture videos using those IPython notebooks, going through doing Python functions, if statements and loops and things. And then here we talk about the basic data structures of Python. And then these are kind of meant to be done next week, although you might want to get started on these. So this, again, I assume most people in this course will be able to pick up Python, at least what you need to know, relatively quickly. But maybe the newest stuff for some people is like using NumPy, right? So this might be the important one for our assignment, where we talk about NumPy arrays and doing vectorized programming. So a lot of the stuff in the first assignment is kind of coming from this one, this lecture video here, the Unit 2-1. Okay, there. So let me jump back here. I'll come back and show the assignment repository after I finish introducing here, but we're done here. So this is what you should see if everything ran. You shouldn't see any errors. So yeah, if you look back through the output of when it was setting up the dev container, it's this is kind of a complex process, so it's not unusual to have errors or things. So if you're having problems with that, make certain you contact me right away. But if it succeeds, it should just come down here. So so let me just show you the basics of what's happening here. So we're actually running a container, so a virtual machine, right? And it's actually running a version of Linux. So it's running just a basic Debian bookworm Linux 12 here inside the container, right? So even though my host system could be Windows or Mac OS, we're using Linux inside the containers. And as is shown here, we're actually running a Jupyter Lab server. So it should be being served on port 8888, like it says here, right? And if you look at the ports, you should see that port is being forwarded to your host machine. So that means even though it's running inside the container, if you go to your host machine, you should be able to access the Jupyter Hub server at the port 8888. And so let's try that, make certain that that's running, right? So if I open up a web browser on my host system and I go to all right, so your home IP address is the 127.0.0.1. It's a special IP address. So that just means look on my home machine, and then the :8888 means look at that port number to see what web server is running there. Okay. So hopefully this is running and accessible. Oh, the way we have the setup here, you might have to actually use this URL. So it might need a token as kind of a password to get in. Might be having some problems. Let's try. doing this here. So I'm just going to copy that URL. So the same one, but we give it basically the password so it'll log in. There we go. Okay. So I guess I didn't need that. All right. So you should be able to get into that. So I don't know. Let me try that one more time. So if I log out here. So, yeah, okay, it's not HTTPS, it's just plain HTTP, which is not secure. That's why I wasn't able to get on when I did it like that. So, if we just go to HTTP 127, yeah, so it will, if you don't give it that token, the way I've got it set up for assignment 1, you do have to, you can't just copy it and paste in the token, which is basically this big string of numbers, or like I showed, I mean, since I'm copying and pasting anyway, I would probably just usually select all that, copy it, and paste that in so I get the password token I needed directly. So, okay, so I'm now actually running Jupyter Lab server, Jupyter Hub server. So I should be able to, for example, open up my assignment 1 Python notebook. So this is one way that you can run notebooks in the container setup that I give for the class here. It's getting Jupyter Lab running through the port that's forwarded from inside the container to your host system. You can actually run these notebooks directly, and that should be set up for you as well. So VS Code is able to run notebooks as well. Let me see if this is working here. So if we open up the notebook, you really shouldn't have the note. You shouldn't be editing the notebook in 2 different places. Okay, I'm going to close this off here and discard any changes that I had. So in VS Code, if you open up the notebook, the very first time, you may not be able to run these things here until you select a kernel. Hopefully this is all set up. So if you look at the Python environments, you'll want to run the, so hopefully you'll see the same thing here. So if you use the opt-conda, that should be the one that was installed for you inside the container. So that is the a good kernel to use. There's probably other ways to do this. That should also allow me, though, then to run these cells here. So, for example, if I clear all the outputs, let me just rerun this cell here. So, like a control enter will actually run the cell here. So yeah, those do seem to be running. Oh, except for I couldn't find that there. So I'll have to check that. So let's check that works from the from running it in the web browser. Okay, so I'm going to discard those. I'm not going to save that notebook. I'm going to reopen it from here. Let me stop that kernel and restart it here. So let's stop our kernel and reopen our notebook. And I'm going to do a kernel, restart kernel, and clear the outputs of all the cells. Okay. Let me just check that this stuff is working from inside of here. Okay, so the Python path, we might need to get the Python path working here, probably as a workaround. This is something that probably should have been set up inside the container, so I'll have to debug that. You should be able to always just by hand append in the Python path. Basically, what it's doing is that we're trying to import some stuff from the assignment utils, which is this file in the source directory. So if we add that to the path, it should be able to find it then. So we shouldn't have to do this explicitly if we set up the Python path correctly. It might not be being set up for you there. So yeah, you might have to uncomment that to run these. That might also work inside of VS Code if you want to run these in VS Code. Okay. So this is a good thing to check. Make certain that you can run the cells. In fact, I usually recommend that you make certain all the cells can run if you run every cell, right? So I usually do like a kernel, restart kernel, and clear the outputs of all cells, like that. So everything's cleared out, and then I rerun everything. So restart the kernel and run all the cells, like either using that or the kernel, restart kernel and run all cells. So those are doing the same. So whenever we give these assignments, all these cells should run. When they run the test might be failing, but it is actually running all of the cells here. So I can tell that it ran every cell because if I go all the way down to the last cell, I see that it actually ran it. This was the 17th cell it ran, and it produced some output, produced some error output from running the cell there. All right, and then kind of a final thing. I'll talk some more about the actual stuff you need to do for this first assignment in class. I'll do this actually next week because I'm planning on doing basically the same stuff I'm doing right now here for our first actual face-to-face class. But yeah, for this first one, you're supposed to actually implement the basic sigmoid function, which gets imported from the assignment tasks. Okay, I'm going to switch over to VS Code. I'm going to actually edit. So I usually, if I'm actually editing, code, VS Code is a lot nicer of an editor than editing code inside of the Jupyter Lab interface. So basically, here we need to implement this function that's described here in a using math.exp, so in a non-vectorized way. So you notice that this output here is coming from when we call basic sigmoid, where we're given an input of 3. Okay, so here we call the implementation basic sigmoid, give it a 3, and we print out the result here. That's after we run these unit tests. Okay? So it's actually returning 0. Right? So if we were to modify this, so it's returning 1, and if I reran the cell, you'll see that it's now returning 1. Okay? But so your goal, though, is you need to get it to pass all these tests, right? So the correct thing for when you give it 0s, it should be returning 0.5, because for this sigmoid function, an input of 0 actually should give an output on the function of 0.5. Right? So I could actually get it to pass at least one of the tests by always just return 0.5. Okay, let's run that stuff like that. So notice we're returning 0.5. So notice, the difference is that we actually passed the test when we're given 0 as an input. We got the OK. So you want to get OKs for all of these. And you need to do that for every one of these where we have a set of tests set up for a function you're supposed to write. Okay. Like I said, I'll talk more about that if people need more help actually finishing these off. But as a final thing, so I've actually made a modification. So if you'd completed having that function written, the way that you submit it for grading is you need to create a commit and push your commit up to your repository. That's how I see it and grade it. Okay, so here, so notice that if I look at my source control again, so I've modified just that line on the assignment task on return 0.5, and I don't the diff on a notebook won't make much sense. But we've actually modified the IPython notebook here. So let's go ahead and add both of these and create a commit from these and push it up. Right. So use good commit messages. So at a minimum, you should have a title. So a title for your commit message and a blank line. And then one or more sentences of description here. So we started working on task 1, the basic non-vectorized sigmoid function. We are only returning hard-coded 0.5 currently, so only passing 1 unit test. Oops. All right, something like that. Your username and user email is supposed to get passed in. It didn't get passed into mine here, so just in case you see the that message here, I need to. This is the step you should have done when you were setting up Git in those instructions. But I can look at my configuration here. I can list it out. So for some reason that didn't get copied in here when I created the container. So I'll just go ahead and set the username and my email. I better make sure you use the same email that you're using for your GitHub, the primary email for GitHub. So I'm actually using this one for my GitHub account here. So now that I have those configured, the username, so those are usually the only 2 that you need to have already configured whenever you make commits and push them. Those get added automatically into the commit messages. Okay. So now it should be happier. So now I actually created the commit, but I haven't actually pushed it. I haven't actually synced it back up to my repository. So I'll also sync it up. So I can tell that, I mean, you might not always get this message here, but I can tell, like in the status here, that that commit that I just made is only on my local system on the main branch. It's not back on the origin. Also, if you look at the lower left down here, this is basically indicating that there's nothing remotely I haven't pulled down yet, but there is one commit locally that hasn't been pushed back up to the origin, to my GitHub repository. So I can sync there, or you can push there, or you can even push here to push it or sync it. All right. So that's the basic. So once you've done that, if you go back and look at your repository, so the way I grade your assignments is there should be a what's known as a pull request called feedback. So the feedback pull request here. So if you go back and look at your feedback pull request, you should see whenever you create a commit and push it, that it shows up here. Okay. So if you're not seeing that, if there's nothing there, I'm not able to see it, right? So I can't actually grade your work until it shows up here in the feedback pull request, right? And those same unit tests that I was talking about, those actually get run here as well in what's known as these GitHub actions or the GitHub autograder. So we can look in there. So I'm not actually passing anything yet. In fact, also it actually installs all of the same environment. So the same Anaconda Python environment with the same libraries and things. So it might take a little bit of time to run these, and then it actually runs the all those tests, right? So I can see at a glance here whether you're passing stuff or not, at least in terms of the tests when you run them. All right, so how are we doing here? So that's the basic things I wanted to show here on using VS Code and how you get access to the Jupyter Lab server and how you do the assignment. Let me show one other final thing here, then I'll stop this video. Let me go ahead and close off these diffs. So when you're done working in a container, the proper thing to do is to do a close remote connection. This is actually like shutting down. It's like performing a shutdown on hardware. So this is actually shutting down the container in the same way. So close remote connection. So once you close it, that the Jupyter Lab Jupyter Hub server is no longer running. So yeah, you can't actually access that anymore. That's why we get that server connection error there. So let me just show this again here. So the kind of the final thing I wanted to show is you also will find this repository useful. So the repository for our 574 machine learning class. And you can clone this, and it also has a Docker container. So this is another way you can test before you work on the assignment, you can test whether your Docker containers are working by cloning this. You don't have write access to this. So like I mentioned, you want to clone this using HTTPS. Okay, I'm going to copy that. I've already got this cloned as well on my local system. So I'll just put in that repository URL. And I don't know if there's a way to change the name here. So I've already got the 574 ML, but so again, if it has the same name, it'll give me another copy of this with like a -1, -2 on there. So I'll just go ahead and do that to finish up this video here. In this case, since I already created the same kind of containers on my assignment 1, when I create the container here, it ought to be relatively quicker to do it, hopefully, here. So this repository is much bigger, so it's actually taking some time to download all the files, but I'll go ahead and open up that repository, and I'll go ahead and reopen up in a container. So yeah, hopefully this will go a little bit faster here to create the container this time. So here's some of the stuff is cached. So some of these parts of the containers that it pulls down to put together to create the full container here. So I didn't have to re-download some of that stuff. Okay, there. So again, we're running, and I'm running the Jupyter Hub here, Jupyter Lab here on the port here. So let me go ahead and if I went too fast on that last time, the output from this goes to this nohup.out file. So yeah, if you do need to find the token in order to open it up in a browser, you can open up that nohup file and search. It should be usually down near the bottom. So I'll just copy that and open it up on a browser on my host system here. So now we're running Jupyter Lab, but this is running the course lecture, the course material. So in the lectures, you'll find all these notebooks which I use for the lecture videos, right? And again, these should all be able to be run cleanly. So if I rerun the whole notebook from top to bottom, every one of these should run, hopefully. If they don't, let me know there's a problem. But for example, I just reran everything on the first notebook for our unit 1 here, which is an introduction to Python and functions and things like that. Okay. Okay, so like I said, I think I got through all the stuff in about the amount of time I wanted to. I'm mostly doing this to check out that I've got things set up for the streaming and stuff. But I think things were going okay, although that's no guarantee that I didn't get a chance because of the weather to actually test it out in the classroom like I was going to yesterday or on Tuesday. So we'll see. Hopefully, it'll work smoothly as well on the in the actual classroom with our face-to-face class with the same setting that I've got set up and working here. So, all right, with that, let me go ahead and end this, and hope it was useful for you. And I will, hopefully see you guys in class, or send me emails if you have questions, things like that. And yeah, see you guys later.